Hi, Neeraj.
Hello.
Hi, sir.
Hello.
Yeah, you can start, sir, and maybe
Yeah.
people will join. So I'm giving you a host.
Yes, good evening to all of you.
Good evening, sir.
We are starting a little early today.
Good evening, sir.
Yes. Nice to see Anka from Hyderabad, Titi from Bharuch, Takar is also from Surat.
Ahmedabad.
Ahmedabad, yeah, okay. Good. So, anyway, without, I think we need meaning another 2 persons have to join. Hopefully they will join, but I'll just start with the basic, introduction. See, this is unit 6 of our the syllabus on operations management and supply chain management elective, which is on operations planning and control. You see, when we talk about anything in management, there are mainly 4 aspects to management, which is planning, organizing, directing, and control. These are the primary functions of management. So when it comes to operations also, there is a lot of planning which needs to happen. Because it is in case of operations, it is not that you can straight away like turning a tap to increase the output. It can't happen, or it's not something modular where you can just add some extra machines within no time and then start and then get more output. So a lot of planning goes on, and many of them takes months and years together to get the facilities in place for the operations to go on smoothly. And in doing so, that is, we need to first of all figure out what is the total number of yeah, I'm just seeing, yeah. What is the total quantity which you are going to produce in at least the horizon for planning usually is say a year, because year is easier to plan, especially for a medium term of planning. And that is first considered as to how to go about that. And then it is broken up at a very gross level. Like, let us say Maruti, when it plans that, how do they plan for how much they're going to produce in a year? We have done forecasting earlier, right? In the subject. So the marketing provides from their information they have and with what they have collected as to how much cars they would be able to sell in the next year. Now, it is the gross, all types of cars put together. But then you just can't produce any vehicle in any color, in any variation, and then put it into market and people buy. No, that doesn't happen. Earlier, of course, there was a time when in India we had only two vehicles, Fiat and Ambassador, and the cars used to be mostly either only white or black. There you had no choice. But then it is no longer so. Not only that, even within the vehicle, there are people want with various combination of features, different capacity of engines, and many other things. The details of planning happens at a smaller horizon when, let's say a month. But certain planning happens in the quarter, because that is when, even the companies, they have a meeting for quarterly projections of whatever is done, some of these bigger companies, and usually even others also. So that is when they say that this is what we have done, and then this is what we plan to do in the next quarter. So that then they plan, then that has to be translated into operational level planning. And that again is at the gross level, or what we call as the aggregate level planning. Now, we will start with that. One sec, just a minute. Yes, here. Right. So for the slide share mode. Yeah. You're able to see, I think, right? Good.
Yeah, yes.
Yes, yes.
Yes, sir.
So, yeah. So from there, it then goes into detailed levels of planning. To materials, and then at the shop floor level, at the process level, and all that. So that is what we will be doing today. Planning the operations, and how do we control the schedules at the operational shop floor level. So a business planning exercise is what first is undertaken. Basically, any plan is strategic in nature and addresses what are the following questions. Should we meet the projected demand entirely, or a portion of the projected demand? The reason behind it is that, do we have the capacity to deliver the full demand? Or vice versa, in many cases, we have excess demand, but are we able to excess capacity, and then we may not be able to produce fully because the demand is not there. Then what do we do with our capacity? What are the implications of this decision on the overall competitive scenario and the firm standing in the market? So you may consciously take a decision on what would be the plan to produce for the year, and it need not be again uniform, because everything has a season. Like even for cars, for that matter, if we talked about cars, there is a season, in the sense that people buy more towards the companies usually invest in the last quarter of the year because they get depreciation and things like that. Some of the others who buy during the major festivals, because that is a thing, and people have various reasons for buying whatever they are buying, and so there is a seasonal variation of demand for any product, for that matter. How is this likely to affect the operating system and planning in other functional areas of the businesses, such as marketing and finance? Because obviously, once you plan to produce certain things, you must get the raw materials and components and sub-assemblies to produce those products. And in time, even like, the number of parts which are there in a car, even if one of them is not there, like, let's say the steering wheel assembly, no, you can't, the car is not finished, you can't even drive it out of the shop floor, right? Similarly, like let us say there are no tires, meaning tires have not arrived, or any one of those parts. So everything has to be there at the time of assembly, and for it to be finished. And then people supply to you only when when there is a smooth flow of money across the business. So that is what the marketing and finance has to take care of. And what resources should be coming to meet the chosen demand during the planning horizon? Resources in the form of not only the capital, but then the manpower which are needed for those resources, and any other utilities which are needed for that, and then storage, warehousing, whatever, all that which are needed. So when we do all these exercise, the aggregate production planning is the first step. That is why we call it an aggregate production planning. This translates the business plans to operational decisions. Now, what is an aggregate plan? Now, we'll see that there is the planning exercise has three levels. The first level is what the overall business plan, which is usually taken at the board level of the company or the senior most management level, which again derives its decision based on the marketing input from the marketing and input from the finance departments or divisions. And this business plan, once it is done, it has to be translated into a production plan, which is at this stage a very rough cut. As I said, only the overall numbers, so much numbers, so many liters, so many kilos, so many tons, so much of square meters, let us say, these are all the kind of rough cut capacity is what is planned at this stage. From there, the next level of planning is the master production schedule, which goes into the details of the products, the requirement, breakdown into bill of material, all that kind of thing. And then from there, translate it into what are all the materials which are required to, what are the sources for those materials, how do we get, how much of that is imported, how much is local, from where they have been transported, all that kind of thing. And then on the production capacity, do we have the capacity to produce in terms of the floor area, in terms of the machinery capacity, in terms of line balance, balanced output, the assembly lines, etc., all that, the capacity requirement plan. The third level is what happens on the month, week, and daily levels, which is a detailed scheduling of what exactly are the different models to be produced, how much to be produced, when to be produced, on what days you will produce what, all that thing. Then after taking the decision, then it goes on to the shop floor level, because it consists of various stages of production, and then the materials have to be fed from the front end till the product is completed with the right quantity and quality of the item across the entire production line. So these are the three levels of hierarchy in planning. The first one was the rough cut plan based on the business plan, which gets this input from marketing and finance. Then the master production schedule, which works out the materials requirement plan and ensured by the capacity requirement plan. And based on that, the detailed scheduling of what is to be produced. And machine to machine item, the stage by stage control of the flow in the shop floor. Now, aggregate planning, production planning, what are all the decisions which need to be taken? What are the variables? And then just to give an example, let us say, which we also roughly talked about earlier, the decisions involve amount of resources, productive capacity and labor hours to be committed, rate at which goods and services needs to be produced during a period, inventory to be carried forward from one period to the next. All three are very important decisions. As I said, sometimes we may have capacities in excess of what is needed, or we may have capacities lesser than what is required to be produced. In which case, we also outsource what has to be done. Then those decisions need to be taken. Again, do we have the skilled manpower to produce this? At different stages of the thing, that we need to see. And similarly, at the what is the daily rate, or whether we need to go in for a second shift, or we have to go for third shift, all that kind of thing. At the and at what times of the production schedule we need to do that. At each stage, what are the risks and what inventory during the processes, that we call it a work in process, if you remember, at each stage, what is the buffer which we need to carry right from the raw material stage to the finished good stage. Like he's talking about an example of a garment manufacturing unit, let us say it produces at the rate of 9,000 meters of cloth every day during the month of January to March. This is what is a plan. Okay. According to the aggregate plan translated into the next stage and then come to the scheduling, this is what has been planned. Now it says increase it to 11,000 meters during April to August. Maybe because from September onwards, August onwards, we have the festival season in India. So we expect, especially September, October, November, Diwali time, and right from starting from Ganesh Chaturthi to, they're all festival times, So let's say that is a decision to increase. Change the production rate to 10,000 meters during September to December. Because once the demand is fully met, then maybe, that we have that month of, December 15th to January 15th, when people don't buy anything, we have peculiar things in our things due to our own customs. So the production rate, the demand says that we need to reduce that and then carry 10% of monthly inventory production as inventory during the first 9 months of production, and work on one shift basis throughout the year with 20% overtime during July to October. Now, this is what the aggregate planning has come up with based on various inputs which they got from marketing and finance. Now, what we need to understand this very simple thing is about units when we talk about, whenever we talk of anything, you need to understand the unit of what we are talking about. Yes, like just to give an example of there are things like phenyl acetic acid. Obviously, you don't produce it, you talk about liters, it may be, of course, it is common also in the industry language to talk about what is a unit. It's a metric tons. Data entry systems, if it is it is in numbers. Mini computers, because there is a huge variations, probably we talk about the value, X factory value of that what is produced. Printed circuit board, square meters. So much of square meters is what we expect to produce during each quarter, or something like that. Alloy iron castings, metric tons. Cement, metric tons. Now, let us say some of the, just for discussion, give me some commodity and see, tell me the unit. Each one of you, tell, starting from Titi, come on. Talk of some item which you are familiar with and what is the unit.
Like, sir, so just now on the starting of our session, we were discussing about the groundnuts.
Groundnuts, okay, groundnuts, okay.
Yeah, yes, sir.
Yes.
So, sir, it could be measured in kilograms.
Correct. Obviously, you don't measure in metric tons because nobody consumes in that. It's easier to understand kilograms of production. So that's a unit to be produced is kilograms. Good. Divyang, any? Yeah.
Pharma tablet per day.
Is that what the
Number?
Okay.
Like 1 CR. 1 CR.
No, I know, but is that what is the common practice in the industry? Now, when you take a balance sheet of, let us say, which is a company, let us say Alembic, what is it? Which company? Alembic, okay. Alembic, if you say in their balance sheet, what do they say in the section on manufacturing? How much they have produced in a year? Do they talk about in numbers?
Yes, per day tablet, 1 CR tablet, 15 CR tablet.
I see. Okay, I accept it. Yeah, because you are from the industry. So that, as I said,
And also there is a powder manufacturing called active ingredients of pharma. They are producing in metric ton.
In metric tons, correct.
Like raw material. Active, those who are used in a tablet.
Right. So raw materials are measured in metric tons and the finished product like tablets are measured in numbers. So many numbers. Yeah, very good. Anka, yeah.
Yeah, hi sir.
Yeah.
My father is used to do the business still now. So
which one?
My father is doing a business, dal mill. So we will be measuring the quantities in tons, or else we will be measuring into the quintals.
Correct. Because you are now selling them in large quantities. See, now is the difference between what Titi says and Ankarao says. Both are talking about the same product. One is at the gross level and one is at the
unit of measure is different.
Because the stage at which it is being sold is different.
Right, sir. So the levels are different from
the levels are different. So the units of measurement for aggregate unit is different.
Yes.
Like Anka's father who produces groundnut, he it's a seasonal crop. How many seasons are there in groundnut?
Groundnut here we have only one season. We used to purchase the dal, ur dal or normal dal.
Okay.
So those things will be reprocessing in the mill and will be selling it to the wholesalers.
Right. So basically it is in quintals, basically.
Yeah.
In all the cases, it is in quintals. Yeah. Right. So that any product which we talk about, ultimately, we need to talk about what is the unit of unit in which we are talking about, It is, you can't talk, let us say we are talking about milk in Anand, we will be talking in so many, we will not be talking in kgs, we'll be talking in liters. How many kiloliters?
Gallon liters.
Huh?
Gallon liter.
Gallon liters, yeah, right. So there it is in liters. So the quantity, the unit of production, unit of capacity is what we need to understand for each product, right? That is. Now, aggregate production planning, why is it necessary? Because there are demand fluctuations. So we need to understand those demand fluctuations, capacity fluctuations, because sometimes what happens is, if some product needs, let us say, water, or it needs power, and then there are differences in supply of basic of these, and sometimes even labor becomes seasonal in many industries. Availability of labor itself becomes seasonal. So we need to understand those things when you prepare, make this planning. Difficulty level in altering production rates. Production systems are complex, and varying the rate of production requires prior planning and coordination with supplier and distributors. Benefits of multi-period planning. Usually what happens, as we told, that it will be at least 4 quarters. The quarterly planning is the easiest in aggregate planning, right? So aggregate production planning is done in an organization to match the demand with the supply on a period by period basis in a cost effective manner. So obviously we can't carry too much inventory. We can't, because that will block your finances. And the best way is to produce exactly as per demand, which again may not be possible all the time. So the framework for the aggregate production planning, you can see it in this simple chart, which says that it starts on the left from forecasting, targeted demand to be fulfilled, that is given to you, then arriving at effective period by period demand to be met. You translate that. What are the alternatives for modifying that demand if there is any input? Like, as we say, getting outsourcing or buying from out, all that kind of thing. Arriving at period by period supply schedules and actual period by period supply schedules. Alternatives for modifying supply. This is the overall framework for aggregate production planning. Alternatives for managing demand is reservation of capacity, influencing demand. Of course, these things don't work nowadays, because what happens, the market, everything is market driven, special tariffs, differential discount structures. But of course, you can always give discounts during, we say, the seasonal discounts and all that, which happen to increase the demand during those periods. Limited period special offers. These are the ways to create and manage demands. No. Alternatives for managing supply could be inventory based alternatives, which are stock out, back ordering, backlogging. In fact, this is one thing which we were in fact discussing in one of our meetings, is that the demand for, let's say, printed circuit boards is largely influenced by the supply of semiconductor chips. If the customer does not receive the semiconductor chips, he doesn't take the delivery of the PCBs which he has ordered. So we go backward, like, on the supply chain to find out whether these chips are have been ordered, they're able to get, and things like that. So carrying inventory, of course, that is the easiest, but then it is costly. Carrying inventory is costly. Capacity adjustment alternatives involving hiring and layoff of workers. Of course, it is difficult to lay off workers, but you can always have contract labor, which is allowed under the law to a certain extent. And a lot of companies use that, contract labor. Varying shifts. As I said, you can do extra shifts during peak demands and peak requirements. Varying working hours by giving overtime, right? Of course, you don't do undertime mostly, but then overtime definitely, in overtime, we have to pay 1.5 times wages for the extra hours rather than the normal hours. A lot of people do that because they find it is cheaper than employing extra manpower, right? And more productive. Capacity, but then there is a limitation also. You can give only that much overtime for a person during a week, that kind of thing. There are labor laws are there. Capacity augmentation alternatives, subcontracting, outsourcing, debottlenecking by providing extra, hired equipment for debottlenecking, addition of new capacity. That is, of course, if it is needed, that even in the long term, it is going to continue. Alternatives for, aggregate production planning alternatives, put in a tabular form as you see here. Alternatives for managing demand, reservation of capacity, planning and scheduling costs are involved. Influencing demand, marketing oriented costs, because your realization becomes lower because you'll be giving more discounts and more incentives for whatever selling and things like that. That is a cost involved. For inventory based alternatives, building inventory, of course, as we said, inventory holding cost goes up. Yes, you also need more adjustments with the banks for holding the inventory. Backlog, back order shortages, which costs you the shortage loss of goodwill costs, because like when you order from your vendor and then suddenly your demand goes down and you say, no, I am not, I can't pick up the order right now. Means, of course, then he doesn't feel good about it, obviously. So there is a lot of goodwill lost. Capacity adjustment alternatives, overtime, undertime results in overtime premium, lost productivity, varying number of shifts, changing shifts costs, higher layoff of workers, training and hiring costs because of the thing, and morale of the employees. Capacity augmentation alternatives, subcontract outsourcing, transaction costs for subcontracting, but then these are fairly well established usually in many industries when you subcontract. Debottlenecking, annualized debottlenecking costs, and adding new capacity is a capacity for cost related to that. Now we come to two basic generic strategies in operations for at the aggregate level. These are called as the level strategy and the chase strategy. Very simple, of course, it's nothing, no big brainer. A level strategy is like, let us say that we talked about that example of that garment industry that producing this many meters and during this month and all that, these 3 months, first 10,000, then after that 11,000 comes down to 9,000 and kind of thing. Suppose in this scenario, let us say that we uniformly produce the same level month on month and quarter on quarter. And whenever there is an excess, you keep the inventory. Whenever there is a higher demand, you sell. Then it is very easy for the production. Production will normally, any production, if you ask any production manager, he will prefer the level strategy. But level strategy means inventory, and of course, even suppliers also would prefer that. Everybody would prefer that. But then inventory carrying cost becomes high in this. So in level strategy, the emphasis is not to disturb the existing production rate at all. As I said, the production, everybody is happy in this thing. But it is not a cost-effective strategy for the company. That involves many costs. So the other strategy is a chase strategy, in the sense that produce only when it is needed. Now, there is another thing also. You must say that it also depends upon the commodity. So let us say, for when you produce something like cars or some of the, you say pharmaceutical products, as you say, which has long shelf life, let us say, there a level strategy is very easy to adopt. But let's say if you are talking about let's say groundnuts, kind of thing, you can't have a level strategy if the demands are highly varying, because there is a shelf life, you don't expect these things to last for more than 3 to 6 months and it goes stale. Yeah. So you can't expect a level strategy in many commodities for that matter, especially perishables, low shelf life items. You cannot have level strategy. So in chase strategy, where no effort is made to carry inventory from one period to another, the supply-demand mismatch is addressed during each period by employing a variety of capacity-related alternatives, which we talked about. Comparing the two, in level strategy, the inventory-based alternatives, aggregate production planning alternatives applicable. APP is not an app, as you say, alternate aggregate production planning alternatives applicable are build inventory and or use backlog backorder shortage. So inventory as a critical link between the periods, made to stock environments, products with low risks or obsolescence, as we say, long shelf life, all that. Chase strategy, capacity adjustment alternatives, overtime, undertime, varying number of shifts, higher layoff of workers. And the other is capacity augmentation alternatives, which you talked about, subcontract outsourcing and debottlenecking. There are no inventory carrying costs from one period to another, but made to order on project environments. Several service systems usually fall under chase strategy, because services, as we said, as a first, the biggest rule is it cannot be inventory. Service cannot be inventory. So it has to follow a chase strategy. Like, let's say a hotel or a hospital, you cannot say that I will take only 100 patients today, every day throughout the year. It's a level strategy. It's beautiful. Everybody in the hospital, doctors, everybody will be happy. But if there is a pandemic, and you'll find that there is a sudden rush of patients, and during festivals, certain thing, I don't know, very surprisingly, there are less number of patients. Either people don't fall ill or they don't want to come into the hospitals, which happens. So there is a seasonal variation even in a service like hospitals. So they obviously cannot have a level strategy. They have to follow a chase strategy. Almost all services have to follow a chase strategy. Production, level production strategy, just an example, the table is self-explanatory. If you say that, in April to March, which is usually our Indian calendar for accounting and financial year, as we call, April to March, the demand per unit is given here month on month based on the aggregate planning. And this is the hours required for production, required per unit of production is this. Of course, that is common because you're talking about the same product, and the demand hours are this much. So number of working days vary in a month, as we all know. And especially like suddenly, if you see in October, there are only 19 days, 19 working days, because there are a lot of holidays during October. We all know that, right? And a lot of festivals coming in. Shifts, working hours per shift is this much. The number of workmen are the same available, 125. So the capacity available then becomes this much, and the demand supply hours, the gap between that becomes this. Now, as long as we are producing to demand without and able to meet the entire without shortfall, then you can have that level production. Again, if the item can be inventoried and have a long shelf life. Now, cost of level strategy, of course, it is again in the same example, he is working out the inventory carrying cost and all that, kind of thing. So it works out to, if you see that producing level and carrying inventory, the cost is this much, based on certain figures which you assume as for inventory carrying. The same product, let us say chase strategy using overtime, under time, certain costs which you have taken into thing, So we take these, and then these are the overtime hours and then under time hours, and then the cost based on that is this, let us say. So chase strategy using hire and layoffs, that also has certain costs, and then you here he has calculated monthly what are all the costs which are involved. These are scenarios, mind you. What we are trying to do is, under each of these three different types of strategies, what will be the total cost of that plan, So then you evaluate the three alternative strategies, for all this, and then arrive at what would be the best strategy, which has the lowest cost, right? Of course, there can be many other things which you may need to take into account, availability and many other factors. But the morale of the workman, a lot of things which cannot be considered in pure rupee terms. But when you do that, you get into how you can compare all that, and based on that, this is a different scenario. Okay. So we talked about that. I think this is a these are some detailed calculations based on that, and based on, anyway, all ultimately it matters is that you work out the costs for each of the three scenarios, the level strategy, then the chase strategy based on the two alternatives, and then you either follow that, or maybe you can follow a mixed strategy. That is what ultimately works out to. Ultimately, see, basically, when whatever you are doing ultimately relates to costs. See, in the very beginning, we say that the moment you talk about operations, it means costs. Every level of operations incurs costs. I can very proudly say that this is the only place in an organization where you generate profit. Because by not incurring costs and reducing wastages of resources, most people do not understand this. They think that the profit is being made by the marketing guys. No, marketing guys do not make profit. On the contrary, marketing guys incur expenses, right? The profit comes from the savings in operations by utilizing the resources, materials, manpower, planning, all that effectively. So the aggregate production planning, you can use different methods, and these are some of the mathematical models. In fact, today we have applications and programs which run for these. Ready-made programs which are available. Of course, those of you who have done, of course, in engineering somewhere you must have talked about linear programming, right, which is there. Transportation model is something which you actually, if you have done operations research somewhere, you would have talked about the transportation model. Dynamic programming is again another type of programming, which are optimal methods. That is, what is the optimum of all the resources and how to, which will give you the least cost to calculate, that is calculated using these methods. Heuristics is if you name the English word, it is like by intuition, rather you can say, by your intuition. Most management decisions are taken by intuitions, backed by certain calculations. You see, this is what happens. So those backing are by some trial and error methods, which you try to do, and generalized search methods, linear decision rules. These are some things which probably be explained. The third method could be a simulation, simulating certain work conditions within your own organization, or a computer-based simulation which can be worked out for planning the aggregate plan. The search procedure usually involves like identifying the parameters set up for the criteria, generate all this kind of thing. Okay, this is a simple procedure. And transportation model involves like this is a typical table feature which is used. Okay, I'll not get into the supply demand. Supply is on this side, demand is on that side. And as I said, you have 4 periods for the year, 4 quarters which are there. Starting with the initial inventory, production at various levels, then carrying over from one to the other, and then finally arrive at the total demand, which is the end of the quarter, at the end of the quarter. Then we have a linear programming method for aggregate production planning. These are all the parameters which need to be used. Not get into that details on the formula for the linear programming, right? Okay. From the aggregate production planning and forecasting, we next get into the master production scheduling, which has links with the aggregate production planning and forecasting. This is now coming to real numbers of what actually needs to be produced, what the correct variations of various different products, this particular item, this much quantity, and that kind of a thing. That is the actual production that has to be done. Right. So from the market, you have the order inflow, which is there. That is one information which you have, of course, from the marketing department. Aggregate production planning already has given you some figures based on the business plan which we saw initially, which again has derived its numbers from the forecasting. So from the two aggregate production planning and the actual orders information, you draw up the master production scheduling, which gives rise to planning the materials, planning for materials, and planning for capacity. Because you must have a capacity to produce, you must have materials to produce. The actual production scheduling which you have derived based on the information from aggregate production planning and the actual order you have received. This then goes into the actual production. And using the labor and resources, the actual production with the materials available from the vendors, that's the actual production. It's a simple flow chart to understand how actually the planning happens. Now, from the aggregate production planning, that is at the quarterly level, which we saw, for individual items, we need to do what is called as disaggregation. Disaggregation is breaking it up into actual types of products which need to be produced, the variations of the products that need to be produced. So let us say for the capacity planned using the aggregate production plan is like say 18,000. Capacity required per unit for 3 different types, say silver, gold, platinum, could be anything, 3 different products, he says, this is the capacity required per unit is this, right? So for this, what is the month on month? Now the planning horizon was 3 months. Now it's broken up into 1 to 3 months. The forecast for the months, the firm orders which actually you received, you see there is a variation, huge variation here. There is a huge variation here. There is a huge variation here. Shaded area represents the master production schedule quantity. You produce this much, you're actually committed to produce this much, actual firm order was only this much. Okay, so master production quantity, shaded area represents the master production schedule. Capacity required for master production schedule is, because that this multiplied by that 0.2, that kind of thing. So you get the actual figures here. So aggregate production planning, we saw, serves to translate the business plans into operation decisions. Decisions include the amount of resources to commit, rate at which to produce, inventory to be carried forward from one period to the next. Aggregate production planning is done to match the demand and the available capacity on a period by period using the set of alternatives available to modify the demand and or the supply. Alternatives for modifying demand include reservation of capacity and methods of influencing the demand during the period. Alternatives for modifying the supply includes the inventory variations, capacity adjustments, and capacity augmentations. So 2 generic strategies we saw, chase and level strategy. In reality, a mixed strategy is used most of the time. And the structure of transportation model lends itself to studying the hello. Yeah, linear programming can also be used to model the aggregate production plan. Master production schedule involves disaggregation of the product information to ensure the required capacity and materials available for as per the plan. So now we get into the next stage of the master production schedule. But the first thing which it involves in master production schedule is the materials requirement planning, which is the MRP. Okay. Now, how are we doing on time? I don't have time with me. What's the time?
It's 5:23.
5:23. Take a 5 minutes break or 20
We
minutes
started. We can take a break.
break.
Yes.
Yes, sir.
Yeah, you take a 10-minute.
Yes,
Up to 5:30.
Yes, sir.
You can.
Correct.
Yes, sir.
Five-
5:30. 5:30 we'll be joining back on the session, sir.
Yeah, sure. 5:30. You take a break up to 5:30. Right.
Yes.
And this is the second part. We will continue. Right. I'll keep the screen on. Yes, good. So we get into the next stage of planning, which is the master production schedule. And before that, we need also to see that we have our resources properly planned. Resources mainly means materials, of course, and also manpower, right? Resources also means money, but then that is not the purview under the purview of operations. Obviously, maybe under the management, general management, but not in the purview of operation. When it comes to operations, we are only looking at the capital equipment which is needed, the materials which are needed, and the manpower that is needed to run, and other utilities like power, water, gases, whatever things which are there. So the material requirement planning, or the MRP, usually it is a computerized information system. Yeah, it could be manual also, but that aids in the planning of materials for the organization. The unique characteristics of the production items takes into account that. And when it comes to material, there is a lead time which is associated. Lead time in the sense, from the time you order and from the time the material arrives in your stores, that is the lead time. The order is sent to the vendor. Vendor accepts the order and order terms. Then he either manufactures or allocates to your order for dispatch from his stock. Then he arranges for the logistics based on the agreement what you have. And then the material arrives in your stores. Then the stores does an inward inspection of the goods, whether the quantity is right, the quality is right, and it is accepted, and then gets into your books, right? So this entire period during which the whole thing is done is what is the lead time, which is there. The inventory status, because that will be varying on a day-to-day basis, and when the goods come in, it will go up vertically by that much amount and gradually keep reducing till the next time when the inventory comes in. So, and the master production schedule to make the material available exactly at the time of production. Now, this looks very simple, but then when there are hundreds of items to be produced, and you are producing in a certain quantity, right, in hundreds again, then it becomes a fairly complicated system. And that is why you need a materials planning system or a software or a, whatever you call it. Of course, we all know that in the broader way, sense, we call it as the ERP. I think you all know what is a ERP, right? You understand ERP? Yes. And ERP is an enterprise resource planning consisting of all the items which are needed for the enterprise resources to be planned, which will include manpower, which will include money, it includes everything, In fact, ERP systems go up to accounting on the one end, and goes into payments to vendors, it goes into the various stages of productions and giving information to as required at the various levels in the organization. And there are huge big companies in the world which do ERP, like SAP, Oracle, all that, kind of doing ERP systems. Materials requirement planning, MRP, is a part of the ERP. It's one of the parts of the ERP. So the logic applied to plan materials could be extended to other resources required in any operating systems. Therefore, these planning methodologies are broadly defined as the resources planning. Since the resources planning for the enterprise, it is enterprise resource planning, right? So that is what it is. It is, in short, what we call as ERP, which everybody knows as the ERP. Planning for materials. There are two types of inventories. The inventory in any operating systems, there is an operating inventory, which is the one which is used from the input stage of production to the completion of the product. And the distribution inventory is from the completion of the product till it reaches the customers or customer outlet. So operating inventory it denotes all the resources already classified into material and capacity that are available for the operating system to consume in the production process. Exhibits dependent demand attributes. Now we'll come to this. Is something very important to understand, but then as we go by, you'll try to understand what is the dependent demand attributes and independent demand attributes. Distribution inventory is meant for market consumption, exhibits independent demand attributes. Well, it is very simple that if let us say if you are making same example, suppose we take cars. The cars are not produced only after you place the order. Cars are produced based on some estimate of the expected demand, which goes from the individual, from the retailer to the stockist to, the distributor, all that kind of thing. And after it is produced, we are not very sure that that is what is going to happen. So it is independent of the demand, that inventory. Whereas when we are talking about production, each of the resources are committed or required for a production which is already scheduled. So the demand for those inventories are already committed for production. So there is a dependent demand. That is what it is, a dependent demand. So they differ in their demand attributes and therefore requires alternate planning methodologies. I think as simple as that. Yeah. So types of inventories, demand attributes, as we see, dependent and independent demand. Attribute to the nature of demand. Dependent demand, there is no uncertainty, for sure. There is a parent-child relationship, which, very simple. Independent demand, considerable uncertainty, independent. If suppose there is a crash in the market or the kind of, we had this COVID-like situation, people don't have money, everything goes haywire. No, there's nothing. Whereas production, if that is hard to happen, that will continue to happen once you have done a scheduling. The goal, make availability to meet requirements exactly. make availability to meet the estimated demand for a targeted service level. Right. This may be translated into an offtake or not. Whereas here you are very exactly sure that that offtake is going to happen. Service level, 100% necessity, feasible to achieve. Here you will never be able to achieve 100%. So demand occurrence, often lumpy, is often continuous. Estimation of demand by production planning is by forecasting. How much to order, known with certainty, this is estimated based on past consumption. When to order, very critical, can be estimated. In independent demand, it cannot be answered directly. You should also think about these two with respect to physical products and service, service items. So that is where you can, if you visualize, then you will be able to understand these attributes clearly. Because services cannot be in. Again, we keep repeating the same. Developing the materials resource planning logic. The basic building blocks are existence of multiple levels of dependency, product structure, bill of materials. Now, what do you understand by a bill of material? There is a, like, if you take the car as an example, as we say, the final assembly of car, in that the car manufacturer does not produce everything. In fact, the steering assembly, the gear assembly, the clutch assembly, the tires, everything is outsourced and then brought into the factory. But of course, sheet metal fabrication is usually done. The processing with related to the sheet metal and fabric, the painting, everything is done inside in the factory. The some sub-assemblies are done inside the premises or again outsourced. And then the final assembly line on which the car is being produced. Each of the items which is required by the factory becomes a bill of material for that car manufacturer. Now, let us assume that there is a gear assembly. The producer of that gear assembly, for him, the bill of material will be the steel that is needed and many other things which goes into making that product. So the bill of material at each stage is the distinct number and description of items that is needed for the production of the particular item. Right. So time phasing of the requirement required at different times in different quantities, determining the lot sizes, because the vendors will not be giving one by one. You see, if you take big items like axles, let us say, it can be unit, right? But then even there also, suppose the one truck can carry 20 axles, let us say. His delivery to you will be in multiples of 20. It cannot be, you can't say that you give me one by one. You can't send one truck, one axle every day. No, because for him then it becomes costly. He's going to say, no, I won't do it. So there is a lot size for every item which you produce. Now that is something which you have to procure rather. Incorporating the lead information. Because for each person, depending upon where the vendor is situated, what is the time taken for him to manufacture, sometimes depending upon the items which he himself has to get, there is a time difference between the order and delivery. Establishing the planning premises, or the premises means it is the assumptions which are there. No, is all that. Of course, here we are taking a very simple thing. Of course, this doesn't exist now. This probably is an old, some 20. Yeah, Rekha madam has come. Let's welcome her. Hello. Hello, I think she's connecting. Yeah. So this is a very old example, but then it is easier to see, if you have seen the old telephone handset, there is a box-like thing, there is a handset which is put on the cradle, right? And then there is a cover plate where there is a dial or a keypad, Earlier it used to be a dial, then there used to be it became digital, it came to a keypad, kind of thing. Just for giving an example that these are the thing. So these are the three items here. Now, the basic, let us say the basic telephone requirement is 100. Now, there are two methods of computation. Let's say on hand, the inventory is 30. The planned quantity was 70. For the basic box, the telephone, the dabba, whatever is there. For the handset, of course, again, for one telephone, you need one handset. So the 100, you need 100. But on the inventory, you had 27, so you require 73 more to complete the 100. Cover plate, now it's assumed that each handset requires 2 cover plates, because in the earlier one, if you've seen, there is the one on the ear, then one on the mouthpiece. There are 2 of them. So you need 200 of that. Inventory was available was 16, so you need 184, right? So you have to see that in method B, the basic telephone 100, on hand inventory is 30, planned quantity is 70. The handset required, I don't know how does it work here. One sec. Is 70 he has taken into. Can you figure out what is he trying to say? 27 planned quantities.
Sir, they have planned quantity 70 on basic telephone requirement.
Okay. Yeah, right. Okay. So the planning methodology is based on that. Okay. So anyway, there are two methods. Basically, you have to. What is important is that there are dependencies. What produces what, and the quantities vary depending upon the bill of material. Like cover plate, the bill of material needs 2, whereas the handset there was 1 for a box of 1. So that is what the example is, only to illustrate that in a very simple way. The material resource planning logic, some of the terminologies is that it's an iterative process of computing all requirements at a level and then move down the level to know that explosion in MRP. We'll try to see what is this explosion. Product structure graphically depicts the dependency relationship among the various items that make the final product. Bill of material, BOM, we usually call it as BOM, is a list of all materials needed to assemble or put together one unit of the final product. So BOM exists in various formats: single level BOM, indented BOM, and modular BOM. Usually this indented BOM is what is used. We'll see again, of course, you will understand indent because you use it in Word and other things. Even in PPT, you use that indent, right? So that is a same logic in that. Okay, now your product tree structure, same telephone, what we are talking about. The final product is the telephone. Telephone is that the old one which you are talking about, not telephone box with a cradle which goes into that and a dial or a keypad, which is there. So that is the first unit. 0. There is a base unit. There is a connecting cable which comes from the telephone line to this one. There is a connecting jack, which there are 2 of them, and then there is a handset. Connecting jack which comes from the line, and one from which goes from the base unit to the handset. Okay, operating unit. This base unit consists of these 4 things. The jack is only a single unit. I think the handset consists of a speaker, microphone, and a cover plate on both the sides. If you can visualize, this is the next level. In this level, the panel board again consists of a button assembly with a push button telephone. Then there is a control panel, which is where the thing is mounted. Now it can go to the next level, which will consist of these 3 items. This consists of these 2 items, things like that. So there can be many, many levels when you have a product structure tree. You can imagine for a thing like a car, how many levels of product structure will be there. A lot of things are parallel like here, but under that again, there will be many, many, many going. So just in nomenclature A, B, C, kind of thing, this is the, you put it up. Now in a single level bill of material, you give numbers straight away, like this, and unit quantity. For each, you need 1. Only connecting cable is in meters. The all others, like buttons, there are 12 buttons are needed. Screws, there are so many screws needed. Control dials, this much. So each of the items of the bill of material, there is an item code, the description, what is the unit, and what is the quantity of that. In the intended thing, there is a base level. It starts from, let's say, 1000. The next level you put in the same level. If it is there, then 10. If it goes to the next level, 11. That kind of a intended thing, as you do in a PPT also. As I said, when you keep intending, just doing the numbers, changing the numbers, and then. So this usually is the intended one is used, the same thing put in that form. Advantage in the intended level is that you know which item goes into which assembly, right? So that the dependency becomes very evident, whereas in a single BOM, each item becomes, by itself. So you can have a modular approach again, like saying that this whole thing is in one shot, and then the next item, this is by thing. Modular and intended are more or less similar kind of an approach. Yeah. Time phasing of requirement. This, you see, at what period you're going to produce. Suppose you're producing, see, the final assembly is in a particular batch. Then it is not that all the items are required on day 1. It could be required at different times during the week. So you can time phase your requirement from the bill of material to say when it is needed. So that is time phasing. Then you have lot size rules. You may have got this done, but the thing is the lot size says that, and as I told you, a very simple example, that that fellow can only send 20 axles at a time. No, he can't send 19, he can't send 21. So suppose you want 25, you have to take 40 and keep 15 in inventory. That's how it works in practice everywhere. So After the time phasing, you need to work out in the lot sizing of the rules, so that the lot size for each item will be taken into account. To get the lot sizing also works when you are, let's say, keeping this material into stores. So when you're keeping the material into stores, when you issue, you don't issue one by one. You issue the lot size to the person at the stage in which it is being manufactured. So it works, different. You don't keep giving one screw by one screw, to the person on the shop floor. You give the entire box or whatever it is. So that is the lot size. So lot sizing rules work on these, economic order quantity, because from our ordering point of view, you again you can't order one item by one item. Based on various factors which go into ordering, in terms of the ordering costs, the logistics costs, and many other things, you work out an economic order quantity that, divided by the average demand during the planning period, gives you the number of periods in which you can get, use that material. So this is how it is there. The impact of lead time is that the manufacture of 200 operating units, assembling of 200 operating units, assembling of 200 base units, and then to a thing. Suppose the whole thing is done in about 8 weeks' time. These items coming in at different times. Planned order release time equal to planned receipt time minus lead time. So the timing is very important when you will get these items. Incorporating the lead time, you can see that lot size is taken into account, the lead time in which the items come in is taken into account, and then you make the final table for that. So back to master production scheduling. So drives the master material requirement planning process with a schedule of the finished products. Quantities represent the production, not demand. Now onwards, we are talking about what is the quantity to be produced. So quantities may consist of a combination of customer orders or demand forecast, because as far as the production person is concerned, he produces only what is ordered to be produced. What is ordered to be produced by the production, the input is from actual orders on hand plus forecast. So, but then for the production, it is just numbers to be produced. So quantities represent what needs to be produced, not what can be produced. So this is also not the thing. So we have the planned order release of the parent item, quantity required to assemble 1 unit of the parent, independent demand of the component as spares, which can be added to that, gross requirements of the component, and this is a formula to calculate that. So establishing the planning promises through materials master production schedule. This is one. I will not get into too much of detail here. Okay. Easier to understand here is a materials requirement plan, inputs and outputs. Input first is the master production schedule. From there, the material requirement planning is done. Inventory master file, what is available currently as inventory. Product structure file, that is, as we saw in the bill of material, the intended structure, and for each item, how much quantity that is needed. Then from the materials requirement planning, the planned order releases, which gets into work orders to the shop floor, purchase orders for the the vendors and rescheduling notices for existing orders with the vendors. These are the 3 things which are worked out. So materials requirement planning, the core logic, if you see the master production schedule, inventory status, the net of the 2, this bill of material explores that to give you what is needed, the net of this minus this. The lot size determines the, together with the lead time, tells you when will you get, how much will you get, based on which you set, tell the procurement to get those and give the shop floor orders, because you can give the shop floor orders only when all materials are available. Because there is no, you can't say that you produce something when materials are not available, or even if one item is not available. So this is the complex of the logic which is needed before it gets into the production on the shop floor. In fact, as I was telling you, I was running a production unit for almost about 30 plus years, because my product was fairly simple in the sense that it needed only about 6-7 basic items. But of course, each of them have about 4-5 varieties and all that, so it explodes into about 30-40 different types of inputs. If I have to produce one particular lot batch today, I have to make sure that all the items required for production on that day is available. You see, it's a complex process. Of course, we were doing it, we were not having a software as such for doing this, but then there is a person who was doing purely production planning, chasing on the materials, making sure everything is there, and his job is before the end of the day, he makes sure that the next day's production, everything is available. You see, on a regular day-to-day basis. So big organizations cannot run like this, so they have softwares to run and also departments to run, which will take care of these kind of things. Developing the material resource planning, master production schedule for the next 6 periods. It could be 6 days also. Product A, component C kind of thing. So we saw in that earlier one, the nomenclatures are broken down into A is a final product, B is C are the sub-assemblies, product structure. So for each one of them, based on the lot sizes and the lead times and the materials on hand, these are all the things we can produce, and that much inventory will be carried forward. Okay. This same thing worked out at the detail level. In fact, I know the person's, his name is Ratnam. That is his job. His job every day to ensure that for about 20 machines, all the materials are for the schedule which was given the next day, materials to be readied. So using the material resource planning systems, the challenges are bad data integrity. This is the biggest problem, everywhere. But of course, today we have, suppose an item is issued on from one stage to another and it is not recorded. The inventory will show that it is so much item is available, but actually physically when you go to see that, there will be no item. No, you can't say, I'm sorry, I missed it, because of that entire production will be at a standstill. So first thing in any planning and production is to ensure that the data is perfect. It is on real time. That is very, very important. It should be a real-time data available, or at least if you know that it is updated, in our case, we could not afford to have a real-time data. So we could do that. It is at the beginning of the day, the data is perfect. because there is a procedure to update all that by the end of the previous day, so that next day morning when you come for work, everything is physically as per actual inventory available. So that integrity has to be there in any material resource planning. Lack of discipline in updating the required databases as and when changes take place elsewhere in the organization. This is a very, very tricky problem in all organizations. Uncertainties associated with issues that lie outside the control of people and the system. Of course, there can only be excuses, but then that should not be allowed to happen, right? So how often material resource planning must be updated and rerun? There is a regenerative method and net change method. Regenerative method is a real-time method, as I was telling you, as and when it happens, but it is automated systems with where the the accounting is happening as and when the event happens. It is possible. But usually what happens, the net change method is taken where, as I told you, in our case, we used to do, we could afford to do it only at the end of the day and beginning of the day. In many cases, it could be shift basis also, end of one shift to the next, beginning of the next shift. The data should be perfect. So handling uncertainties affecting the system by incorporating. So for that only you keep some safety stock, because the data may not be accurate, and safety lead times from one process to another process. That is between the processes. Incorporating safety stock, of course, this is a level of detail which probably we will not get into. The next concept is the capacity requirement planning, or CRP, which we saw that you needed the material resource planning and the capacity requirements planning together becomes the master production schedule. So we'll look at now the capacity requirements planning, the material resource planning, planned order releases, and you have a process plan and a capacity status available. Together formulates the capacity requirements planning, which results in the loading schedule for each resource. See, basically, the plan for the, let us say, the next shift or the next day can happen only when you know for sure that these systems are working, the manpower is available, and all other supplies and are again allocated to that. So that is what is the capacity requirements planning based on these three, and that results in the loading schedule for each of the resource. So together, the material resource planning and the capacity resource planning, this is what it is. Input for this is the bill of material. Input for this is the process plan. Input for this is the MPS, master production schedule. For this is the materials resource planning. For this, the lead time data, in this, here also the same thing. Inventory status, that is a capacity status. Why capacity? Because you have different machines working, and suddenly, let's say there is a breakdown and something is not working. So you can't assume the same thing going to happen the next day. Manpower, as I said, some people have applied for leave or long leave, and people are not available. So that capacity will not be there. So the planning here is different, planning here is different. So here the lot sizing rules apply, here that there is no concept here and there. Output criteria here is issue purchase orders for vendors, work orders to the shop floor. Here capacity loading schedules and capacity usage profiles in this case. Okay, how are we on time? 6. Okay, Then I'll try to. This is the third stage which I was telling you that we'll be doing, third level of the topic on operations planning and control. There is a, you must have heard of this JIT. What is JIT? Just in time. See, this is a Japanese concept where, see, for many reasons, Japanese have their own philosophy and concept, which is most of the times totally different from what the Americans do. If you see, America is a very large country. They have a lot of resources, a lot of space, and they have enough things to waste. Japan itself is a very small country. There are no resources available, and they have to make do with their limited space, everything. I mean, whatever is there, and yet they are on top of production and many other things. They could do all this only because highly disciplined way of production to ensure that there is no material waiting at any stage. What is required is immediately got produced, given to the next stage, when that is again produced, and then finally it is sent to the customer. At each stage, when the literally inventory is zero, let us say, that leads to just in time. Now, I'll give you an example. This was something which long back, almost I think close to 40 years back. I was in Japan to take an equipment which is a 100-foot long equipment in linear assembly line, and these guys were assembling that line in a port city called Yokohama. And why they were doing it? Because it is very easy for them to assemble that line there, and immediately after the assembly, it is broken into 5 parts of 20 feet each, kind of thing, packed and put on ship. Now, mind you, there are hundreds of parts which are needed to produce that assembly line and test it, get it certified. Let me tell you, this entire process on a leased facility took 3 engineers, just 3 days. Mind you, they started, for them, Saturday, Sunday is a holiday. Friday evening, that main engineer has already booked for a 7 o'clock flight to go on a holiday somewhere. He's so confident that he will finish the job. We started on Wednesday morning, early morning. In fact, he picked me up from Tokyo, from a hotel. Yokohama is about an hour's drive. We reached by 9 o'clock. And from then on, we have worked non-stop, but of course, up to evening 6 o'clock only. And every single part, motor from small company, big company, items, all just came at the required time with no inventory. And the whole thing was assembled. 5 o'clock on Friday, the Lloyd's inspector came for inspecting the equipment, gave the certificate at 5:45, then handed over to the packers. 6 o'clock, we all left. Clockwork, meaning I've seen, you have to see this kind of a thing to believe actually how it happened. That is possible only when there is an entire supply chain works, diligently without any excuses, any this. There cannot be, there is not even a room for an excuse everywhere. That is precisely what is this just in time. The notion of waste in any operating system, there cannot be any waste of time, waste of materials, waste of the quality has to be good, absolutely perfect. So just in time as a philosophy of elimination of waste, as a deliberate and systematic attempt, and on a continuous basis. It has to be day after day, week after week, month after month. It's not just a one-time philosophy. This is an analogy given on the just-in-time manufacturing water flow analogy. You see, there are so many things under the water, like we say, the iceberg. What you see on top is only a small level. What is there at the bottom is thing. The problems are unrealistic schedules, machine breakdowns, lack of training, variable processing times, defective or poor material, inadequate information, behavioral managerial constraints, bottlenecks, quality issues. All this is there under the water, but the ship has to sail smoothly. Everybody down along the entire route has to take care of this and not give any excuses there up. That is when just in time will work, right? And in Japan it works. Here also in India, many companies have adopted just in time. They've trained their vendors very well, made sure that they also follow, and then it works. The core logic in this is that if you see, it's a very less material, labor, indirect costs, and better quality is a total outcome of the just-in-time. Reduction in lot size, just-in-time production, quality control, smoother output rates, that result in this, which is fed by heightened awareness of problems and causes. That is why the Japanese talk about the total quality management and statistical process control. Process control is more important than the end inspection. And that is where they are able to achieve all this. Deliberate withdrawal of buffer inventories. So that when you don't have a buffer, you have to work to ensure that you produce. You see, and when you have a buffer, you will say, anyway, that is buffer is there, so we can take it easy. So the line or the rope is kept tight, as you say, keep it tight all the time, things work. If you leave it loose, then everybody takes their own loose, and then it leads to a total chaos. So the just-in-time philosophy is that basically keep the rope tight, right through the supply chain. Just-in-time logic, withdraw buffer deliberately, because when you don't have a buffer, you know that you will have to keep up to the schedules, thereby expose hidden problems in the system, identify solutions to the problems, implement and attain smooth production rates, repeat the above process. Just in time, overall impact, faster feedback on quality improvement, tightly linking preceding and subsequent processes, increased responsibility effects. This is a very thing. The moment you remove buffers in terms of inventory, everybody has to work to make sure that the next person is fed in time and in quality. That is the concept in where actually the American management was always talking about buffers, inventory, and all that kind of thing. These fellows just talk the reverse, Japanese. JIT manufacturing, the basic elements, manufacturing system should conform to your flow process. Total quality management, as I said, that is the underlying factor about the thing. Kanban-based scheduling. Kanban is nothing but, see, the Japanese believe everything is to be visual, Whenever you do any system, it should be a visual thing. Like when you put it on board, we can make it very simple. Use some sticky pads. Depict everything in a flow chart kind of a thing. Don't write long processes like what the Americans do, For them, everything has to be legal document. So they will write some 100 pages for what you can put it in one sheet, So the systems are different. Here, it's a Kanban based scheduling, standardized containers, everything in whatever things are carried, all that. Constantly eliminate waste, setup time reduction, lot size reduction, inventory reduction, removing Kanbans, quality improvement, small group improvements, defect-free supplies, supplier collaboration. The last one is very, very important. In the American system, basically this vendor and the, your vendor is always in an adversary position. They always take advantage of a vendor. The Japanese look at vendors as their own sister companies. In fact, I've seen this happening, The same example which I was telling you in Yokohama, when the thing was assembled, I asked him, who is going to supply this and all that? He says, my sister company. And I was saying, you got so many sister companies, kind of thing. But actually, they are vendors. Their terminology they use for vendors is the sister company, So you can imagine, even in our Indian thing, the moment you say there is a sister, the relationship is different, You have a very wholly aligned thing with this. So they actually call the vendors as a sister company, That is the supplier collaborations are extremely important, The trust and other things which flows into that. The manufacturing architectural changes for JIT is that instead of a pyramid-based system or a function-based structure, you have a flat structure, product-focused structure of the entire setup. Then setup time reduction, of course, he has given an example where you can possibly, setup time is something which eats away into all our anything which we produce. In fact, one of the techniques which the Japanese talk about here is called the SMED, or single minute exchange of dice. Of course, this was something which the Sony Corporation propounded in that you change over from one process to another process in 1 minute. I don't know, there was a some WhatsApp thing was floating around some time back, in which how the entire Shinkansen train in Japan gets cleaned in some 8 seconds or something like that. The number of people when the train comes and stops, just like we know the Formula One racing. In Formula One racing, how the entire changeover, that pit stop happens in so much time. That is exactly what. Why can't you use the same philosophy when you have to change over from one to another in a in manufacturing? So instead of talking about SMED, we can even talk about F1 Formula One pit stop philosophy, for changeover. So that is the kind of thing. Reduction in setup time is something very, very important. So I was telling you some time back, in these South Indian kitchens, if you see in these hotels within a small space, they will produce some 100 varieties of items and or different types. And then you order, everything comes within 5 minutes, it's ready. It's like, that is why they have more customers. If you're going to take half an hour for each item, and then it becomes a fine dining kind of a thing, you'll hardly get 100 customers in a day. Those people serve about 3,000 customers in a day. Yeah. So push scheduling logic and pull scheduling logic are there. Pull in any philosophy between push and pull. Which do you think is good? It's a very simple thing. Between push and pull, which is good?
Push.
What do you say, Titi?
Push, sir.
See, okay, even if you take an item in your own house, when you push, you use more energy, or when you pull, you use more energy.
Pulling.
Pulling or pushing. See, when you put, okay, so if you studied physics, when you say when you push, the force goes downwards.
Okay.
So there is more friction. When you pull, the force is upwards.
Upwards. Yes, sir.
Right. So there
Right.
is less friction and it is much easier.
Right.
Correct.
Pulling is easier. Yeah.
In any of these kind of a thing, when you push, there is more resistance. When you pull, there is less resistance. Right. So you apply the same logic. After all, if you are doing that same logic in the scheduling, from forecasting to planning to all that, results in finally into the product assembly into finished goods stores. From here to here, you're constantly pushing at each level to ensure that you get here. This is the typical push scheduling, where forecast drives production. What the Japanese system, what they call, is a pull scheduling. Customer triggers production. In fact, in the days where only the fax machine was there, fax machine. I don't know whether you have seen the fax machine.
Yes.
Now that there are 2 Gujaratis only in my this thing, I can tell you there was a joke. Jab fax pala, first it was introduced. A Gujarati businessman sitting in London was very happy. See, earlier all the messages used to come in English. He has to understand and all those kind of thing, because the system was like that. Jab fax aa gaya, so very simple. Ahmedabad se, the person writes in Gujarati, sends a fax to the person sitting in London, and he has got it in his own language there. Right? So he used to say Gujarati here, Gujarati there. Saruche.
Saruche.
Saruche. See, the system becomes very simple. Correct. So customers' language was, both are talking the same language. So in a pull system, basically it is a customer which drives the production. If I am able to produce, it's a fact that, I go to a car showroom, let us say, okay. Imagine a system whereby I decide all that which I need. Now it is that I can give you 2 days or 3 days time for me to deliver the car completely. That's a smallest lead time. I send this order to the unit from where I don't keep an inventory at all. I send it to the place where it is final assembly is done. In fact, the same logic is what Michael Dell followed for computers. Because computer configurations vary a lot, even for a single customer, he needs maybe 3-4 different types of computers. You can't keep that much of inventory, the varying sizes of varying input, output, the capacities, this, that, and all that kind of thing, So you give a specification, it is assembled and sent to you within, let us say, 48 hours. Now, that's an ideal situation instead of keeping different types of inventories and producing it from various places. The pull strategy is the best strategy, whereby the inventory at every point is the least. Right? The variety is the least. You are creating variety. You're not creating variety and producing into it. Now, multiplying that much variety at each level. we also, if you see, very simple is the Punjabi kitchen, like, basic masalas, basic ingredients are the same. By that time when the customer orders, you just put all that, and then the thing is ready, item is ready.
Correct.
Just like the same thing, like the restaurant kind of thing. Restaurant doesn't produce and keep. It only makes everything ready and, sub things ready. And even for that matter, pizza also, when you order, the pizza base is there, various ingredients are there. The moment you ask the different combination or a Subway sandwich, whatever you can think of, everything is full strategy, full scheduling. Imagine if every single item which is needed works towards a full strategy, then you will have minimum inventory across the entire chain. Right? That makes it the next concept of what is called as a lean manufacturing. You must have heard of lean manufacturing, right? Huh? So that lean manufacturing is what happens when there is a full scheduling. Okay. So push and pull impact systems. So we have seen that ultimately the full scheduling works better, but then the entire system must be well oiled. See, that I said, the rope has to be tight. That, everybody must be at their peak performance, right? The entire chain. So the Kanban, as I told you, is a visual method of managing workflow at the individual and the team level and even organizational levels. Now, there is type of Kanban. I will not get into that, working the dual card Kanban, kind of a preceding process, a succeeding process. A little detailed, I think I'll not get into that. This is a visual way of depicting how the process flow happens in the organization, which is clearly understood, and creating a pull system will ensure that the process is smoothly done. Okay. Now, I'm not getting into the various Kanbans at this process. The Lucas TVS in India is also following what is the JIT process. These are some Japanese terminologies like Jidoko and all that. 5S you must have probably done or will be doing in the TQM, right? So this is what it is. And just-in-time manufacturing is the unambiguous definition of what constitutes waste in the system. There should not be any waste. There should not be too many buffers. There should not be much inventory in the system. It should be totally lean, and it should be a full system which will work efficiently. That, in short, is what is the best system anywhere possible. Okay. So that is what is there for today. Okay. And I think I have managed to finish just 3 minutes out of schedule.
Yes.
Okay.
It's okay, sir.
Okay, sir.
Okay.
And sir, please share this PPT, sir.
Yeah. I'll share it. Definitely I'll share.
Okay.
Yeah. Last time also you got, na?
Yeah,
Yes,
you
sir.
got, sir.
Yes, sir.
Yeah. Right. I'll share the PPT. Because then you can go through all those tables and other things,
Yes,
try
sir.
to work out all that, try to understand, all
Yes,
that.
sir.
Yes.
It would be
Frankly
easy to
speaking,
read.
sir, time is actually what I'll do. I'll before 1 hour of lecture, I'll go through that our old PPTs.
Correct. That's true. Absolutely. Correct. Very good. Excellent. Right, Devang?
Okay, sir.
Like
Good night, sir.
Yeah, good night.
Thank you,
Because
sir.
I have
Good
now the
night,
next
sir.
program 7 to 9. So
Yes, sir.
Okay.
Okay.
Yeah.
All the best for that, sir.
Yeah. Okay. Right.
Thank
Bye.
you.
Bye.